Hello, I'm Zixuan. I'm now working as a research assistant at Hong Kong University of Science and Technology, Guangzhou, and I will be presenting you our paper titled No More Head Turning, Exploring Pass-Through Techniques for Addressing Rear Interruptions from the Front in VR. VR is designed to be immersive, but real-world interruptions are unavoidable. Someone might walk into the room trying to interact, or an object might fall, making some noises. Users often need to check and respond, and Pass-Through allows them to do so without removing the headset. But there's a challenge. Pass-Through works well for front interruptions, but what about when something happens behind the users? For interruptions happen in front or to the side, a slight head movement is enough to check. But when something happens behind the users, they muster their entire head. This is problematic. It can disrupt immersion, cause discomfort, and can even lead to motion sickness. Previous research on interruptions usually assumes it happens in front of the user, but that's not always the case. In fact, the direction of interruptions, especially those from behind the user, has often been overlooked. So, how we can improve real awareness without making users turn around? That's what we explore in this work. We mainly conducted two studies in this paper. First, through study 1, we explore VR users' pass-through use for interruptions. In this study, we investigated how the direction of interruptions, front, side, and rear, affects VR users' willingness to use pass-through. We conducted semi-structured interviews and simulated interruption scenarios. The study involved 13 VR users. We made some findings from this study, which laid the foundation for study 2. In study 2, we proposed and evaluated 3 innovative pass-through techniques to improve real awareness during interruptions. We compared 4 conditions, including 3 new systems and the baseline. This study involved 24 participants and used the within-subject design. In both studies, we used the Pico 4 as a VR headset. In study 1, we started by asking about their past experiences with interruptions while using VR. Then we simulated different types of interruptions in VR, from the front, sides, and rear, and observed how they responded. Afterward, participants discussed their reactions, and we analyzed their feedback using a semantic approach. Our study found that most interruptions come from bystanders. Pass-through is useful for checking what happened, but direction matters. Front and side interruptions were easy to check, while rear interruptions were often ignored because turning around was inconvenient, uncomfortable, and broken immersion. This highlights the need for a better way to handle rear interruptions in VR. To improve rear awareness in VR, we designed 3 pass-through techniques that allow users check the rear view without turning their heads. First, full rear pass-through and pause. Pauses the app and show the rear view right in front of the user. Next, a rear pass-through window adds a small rear view window while keeping the app running. Lastly, rear pass-through AR replaces most of the view with a rear feed but keeps key virtual elements visible, so users can stay in the app without pausing. All 3 techniques mirror the rear view, similar to how people use rear view mirrors in real life. These 3, along with a baseline condition, full pass-through and pause, form the 4 conditions in study 2. In the experiment, participants played a simple fine VR game inspired by Fruit Ninja, where they sliced fruits and avoided bombs to score points. While playing, they encountered 4 types of interruptions, chosen from study 1 as common real-world distractions. The first one is someone entering the room and trying to engage with the user. The second one is a backpack falling off the table, making a loud noise. The third one is two people laughing nearby, drawing the user's attention. The last one is someone calling out to get the user's attention. To maintain consistency, these interruptions were all pre-recorded in 360-degree videos. Here is a video showing the four conditions.
Hey! Is this your bag?
To evaluate the effectiveness of the pass-through techniques, we measured these metrics: game performance, system usability, workload, presence, and motion sickness. Our hypotheses were: Hypothesis 1. The three proposed pass-through techniques can help users identify rare interruptions without negatively impacting game performance or reducing system usability. Hypothesis 2. The three proposed pass-through techniques can reduce users' time and physical effort in addressing interruptions, minimize disruption to immersion, and alleviate motion sickness. And here are the results. First, there were no significant performance differences across the conditions. And for the system usability, we found that the three proposed pass-through techniques reduced perceived disruption compared to the baseline, without causing users to focus too much on the real world. Additionally, full rear pass-through impulse significantly outperformed the baseline in frustration, efficiency, useful information, and communication. We found that all three pass-through techniques reduced users' perceived physical and temporal load. Compared to the baseline, full rear pass-through impulse reduced effort, while the other two techniques reduced cognitive load. We also found that all three pass-through techniques enhanced presence. Regarding motion sickness, only full rear pass-through impulse reduced overall motion sickness compared to the baseline, but all three techniques reduced users' perceived disorientation. For the ranking results, full rear pass-through impulse was the most preferred option among participants, followed by rear pass-through AR, then rear pass-through window, and finally the baseline method. Our results support H1A, showing that the three pass-through techniques didn't affect game performance compared to the baseline. We also support H1B, as these techniques help users stay immersed without focus too much on the real world. For H2A, these techniques reduced physical and time demands compared to the baseline. Our results partially support H2B. Only rear pass-through AR show a higher level of immersion. As for H2C, all techniques reduce disorientation, but only full rear pass-through impulse reduced overall motion sickness. To sum up our findings from the two studies, users were less likely to use pass-through for rear interruptions compared to front or side ones. We found that full rear pass-through impulse and rear pass-through AR were the most effective method. While providing rear awareness in front of the user works, there are still some challenges. Interruptions from the sides need more attention, possibly with head tracking or 360-degree cameras. The mirror design works well, but needs adjustments to avoid confusion. Lastly, switching between views should be smooth, with an easy input design to minimize effort. For further details, please refer to our paper and don't hesitate to reach out if you have any questions.